My name is Shibasaki from the University of Tokyo. I'm one of the chairs of the Moving Features Week. Anyway, at first, let me start with some sort of the use cases. And actually, this movie is created from the 1.5 million people trajectory data that are acquired with smartphones and also the feature phones equipped with the GPS. Actually, this is a kind of one-day record. On March 11, 2011, actually, on that day, Japan was struck by a very great earthquake. And Tokyo, yes, this is the morning rush hours. You may see so many people are anyway gathering going to the center of Tokyo as the morning rush is almost over. And also you may see here, this is a kind of Tokyo Disneyland. The earthquake occurred at 2:46 p.m. and all railway service stopped. So you may see the small dots moving slowly. Actually, they are the people walking or marching from office to home. So as you know, Tokyo is also a big city, so many people have to walk at least 10 kilometers and sometimes 20 or anyway 30 kilometers. So anyway, this movie successfully depicted such kind of the behavior of the people under some sort of the images. And this is not the special data because this data are collected through the navigation services of the mobile phone. And of course they clicked, I agree to send the data. And anyway, this kind of data are collected every day on the real-time basis, at least for the past 5 or anyway 6 years. And recently, we have several demands or requests of combining different types of moving objects for the better services or for the more value-added services. For example, in this case, the moving feature data from the traffic simulation and the people evacuation simulation are combined to develop a kind of decision support system for the disaster risk management, specifically for the tsunami countermeasure and planning. And you may not want to see only these kind of very serious disaster scenes. At the same time, you may see more enjoyable events through the mobile or the moving feature data. This is the Tokyo Marathon last year. It attracted more than 30,000 runners. And amazingly, many of the runners carry the mobile phone to take pictures, tweet, and upload the pictures for their Facebook. So the marathon actually started 9 a.m. in the morning in front of the gate of the Tokyo Metropolitan Government Office building. So at 9 a.m. you may see many people start running like that. And also at the same time, you may see the pictures uploaded through the Twitter, including the keyword like Tokyo Marathon 2013 or something like this. Actually, that corresponds to the density of the runners. I mean the moving feature density along with the marathon route. It's almost 5 hours from the start, but still many people are running. And anyway, you may see them even at the end of the marathon runners actually have arrived at the goal point. Okay. So the interoperability issues that we are facing is that we have to combine different types of the moving feature data from different sources. And we have some sort of the differences in data format or something like this. And this is the result of our study on what kind of existing standards can be applied for handling the moving features. You may see this column. And also it includes the system layer, application layer, and the data description layer. Actually, for the conceptual models, the ISO 19141 was already proposed in 2008. But it's just a conceptual models, no implementation. So our goal is to develop the implementation standard based on that ISO standard. And at this moment, our focus is on the designing the standard encoding rules or kind of descriptive description models. This illustrates how the conceptual models proposed by ISO look like. So anyway, it's a combination of leaves, and the individual leaves are connected along with the timeline, and that will generate a kind of prism. And in order to develop the implementation standard for that conceptual models, we combined two different approaches. One is kind of GML-based approach or XML-based approach. Another is the CSV-based approaches, because in many applications we have to handle the millions of the data. So for the XML style, again, the moving object can be 1D, 2D, 3D, and also, of course, 0D is a kind of point. However, many applications requires only points. So at this moment, we focus on the 0D, or the point moving object. And in designing XML-based encoding rules, actually, this is how that moving point data look like. It's very simple. And in designing the XML-based encoding rules, actually, we make some kind of a comparison. For keeping the consistency within the OGC standards, probably full GML implementation sounds more appropriate. However, the data size becomes much bigger than we expected. So anyway, we decided to apply only some portion of the GML to the encoding of the moving point data. And also for the CSV, actually, as you know, that it is a very simple approach, a simple format, no need to develop any specific parsers in handling the data. That is the advantage of this kind of approach. And this shows how the simple CSV look like. It has some sort of headlines and also the trajectory lines. It's just a combination of the coordinates and also some kind of additional attributes such as walking or driving a car or something like that. And also in parallel with that, we have developed the reference implementation. That is a plugin software for the Google Chrome. And actually, it enables you to handle very easily a larger number of the moving points as a kind of, let's say, movies or something like this. And also you may attach some sort of the attributes. And actually, you can just download and install it if you have a Google Chrome. And this is a schedule. Actually, we hope that we will publish this standard at the end of this year at the Tokyo TC. So anyway, I appreciate your attendance to the Tokyo TC. Thank you very much.
Can anybody think of a way to use moving feature data in an augmented reality use case? You bet, said Simon. Good. Hold that thought for coffee break. Thank you very much. I would like to finish before the end of the period that was supposed to be our coffee break. So I think, Raj, you're going to speak to us for a few minutes about the Open POI registry. Hello? Yeah. Raj. Raj just flew in this morning from Boston. He's an OGC staff member. And to give you a little bit of background about this, it was a project that I think it was, 4 years ago, started in the W3C as a points of interest working group activity and specification. Unfortunately,
Okay.
The registry is, well, I think you can tell us exactly what it is.
Okay.
You're on a double screen, right? You're on a, as we're seeing here. Marvelous.
Perfect.
Thank you.
Okay, so I have a bunch of slides to go through. So we're already over time?
Right? Yeah, we're already over time.
Okay, so basically, I won't get into a lot of details about the format, technical details. I'll just try to stay high level. So that was a nice introduction, Christine, thanks. So we have points of interest work going on within the OGC, kind of on two fronts. We have this points of interest database, this live working website with millions of points behind it and a web services API and a little bit of mapping, which was my experiment to play around with the ideas that came out of the W3C work. And then that's continued on, and but as we brought the specification work into the OGC, that gets modified as the standard changes. So I will first talk a little bit about the OpenPOI service, and then talk about the standards working group activity, which is a great time to be getting involved in that, as we're really going to be gearing up to finish it off this year. So I'm going to skip some of these. It's a POI database, like every other. I think people here know POI databases pretty well. It's very open. The data is open. The API is open, and you're even sharing code. Right now, it's mainly an aggregation of DBpedia, OpenStreetMap, and GeoNames. GeoNames itself is an aggregation of a lot of other sources. I don't try to bring all the data in. I just really want to create an index, a big index, POI index, and link to all the other databases. One thing this format and this database has, and a lot of others don't, is aspect of time. So you can specify that a POI began and ended at a certain time. So that's helping with the China historical GIS, and that came out of a lot of the needs of this historical gazetteer community I work with a little bit. I'm really concerned with input on how people feel about OpenStreetMap and their share life license, and it's been, every now and then it comes up as a big topic, and people are afraid that aggregating with OpenStreetMap is going to pollute your database and make everything open. So I'm a little bit worried about that, and would like more input on that. So it started out as, what we're working on in SWIG is an XML output, and then we're going to work on a JSON. The W3C work started off as just XML, but as the years go on, JSON has become much more popular, and I think that might be the primary format that we support at this point, depending on how people feel. It may even go all the way to having it maybe primarily GeoJSON. And right now, you can get all those formats out of my implementation, the OpenPOI database. I'm going to skip all this description of the format. So basically, I'm going to go really fast, I won't skip it. So basically a POI has a name, a description, or actually a primary name and any number of alternate names, a primary description, any number of alternate descriptions, an ID, which is very important, a location, and then categories and links. Categories can be used for lots of things. Ratings, normal categorization, land use, land cover. You can do a lot of things with the category term. Links also, you can do a lot of things with it. Just like in HTML, a link can link off to a lot of different things. You can specify the link as being related information, or an icon, or a picture of the POI, or a 3D model of the POI. That's where you can really bring in lots of different things. I'll skip all the example here. And there's a very light, kind of like GeoPackage, there's a very light, undefined place for metadata, which I don't think we're going to do better this year, but maybe in future years. There's also a place for specifying authorship and licensing. So that's the very quick overview of the POI format, and that's all implemented. I won't get into this example very much, but even though there's a lot, the schema can look pretty detailed. I don't see this very well here. I don't know if you can see it very well. But you can do if you want to do something simple, I think it does a good job of doing something simple, and you can get much more detailed and complicated if you want to. So this is Boston, the label is the name. Boston is the primary label. Here's a description. You can put all kinds of metadata like when this was updated. The author, this description came from Wikipedia, so the author is a child of the description. Here's when you use a category, term is city, and that city name, the name city, is defined in this URL here, usgs.gov, place types. You can get a much more formal definition of city. Start time is 1630, September 17th, 1630. This might be, I don't know if Boston was really formed that accurately. And then you have some links which go off to canonical link to this record here and other places where there's POI definitions of Boston on Wikipedia and GeoNames. And this example is years old. There's probably an OpenStreetMap link in there now too. And then you have the location, which is defined as a point. You can have multiple locations in this schema. You could also have a polygon if you wanted to. And you can get into all that stuff through the API, and there's some examples, and you can get these slides later. So you can get at the POI with an ID, you can do bounding box searches, there's a WFS interface to the information, and you can do time and spatial searches at the same time. There's some more examples in this presentation. I'm going to stick with the next two slides for just a minute. So my output, this is really a research experiment in a way on how we can integrate geographic information better into the web. And so every time you get if you get an HTML output from this database, OpenPOIs, you have integration with schema.org stuff. You have a lot of microdata. Actually, that's the next page. You have a lot of microdata scattered throughout. And you can take a look at the HTML in detail and see how we incorporated the location information from schema.org and the description and name and some other things there. And we also have really just the HTML interface, the user interface stuff, Facebook integration, Flickr pictures coming in. When you hit a POI, it'll go grab the 4 or 5 Flickr pictures that it can find in the same area. Facebook data on every page, Open Graph, Facebook Open Graph information in there. So really that's just an experiment to see how search engines are going to catalog that and bring this database into the web.
Has anybody used it for augmented reality experiences?
Not that I know of, I hope so soon.
If somebody needed to do that, would they come to you to ask for support? And,
Yep, they could ask for support. You can play with the API. You can probably go far with these definitions. This API is completely open. You can just start using it.
Okay, let's Larry, you have a question?
So I'll ask my answer to your question. I think in this context, because obviously we produce into your catalog and put it on the database is integrated, like the USGS, their elevation maps, potentially add a gets elevation to these longitudinal points, since you've got it all there. Which would be super useful for, I mean, we don't know until the call that the restaurant would be marked as the base of the building instead of where it is in the building. But in a place like San Francisco or wherever where there's lots of hills, knowing that a restaurant, at least in my elevation, is certainly going to be super useful for
Yeah, right now this database is heavy on administrative places, because I couldn't find any. I wanted to keep it open data, and couldn't have yet to find any source of commercial businesses that wants to you have an open data policy. So still struggling with that.
Yeah, while you were talking, I was looking around the stuff around campus. Even there's lots of it is just 2D points, but it's
Mhm.
Okay, John, you have a question, yes, please.
Okay, I've got a unique perspective as a utility. When you call your utility from your home phone, your cell phone, you told your utility your cell phone, and you say, my lights are on. And you use your IVR, Interactive Voice Response System, so you're talking to the machine. It goes out and it says, it goes out and checks the outage management system, comes back and says, Mr. Johnson, you're part of a known outage, or estimated time of restoration is 6 p.m. Okay. Now, people are out and about, and they don't call the utility, they tweet their friends, and they say, hey, my power's out. Or they post it to Facebook, my power's been out for 2 hours and nothing's been done about it. And utilities want to be able to harvest that information and make it as reliable as the IVR, because with the IVR, they've got your phone number on record, and they can tell that you're a legitimate customer and you're not in Uzbekistan spoofing somebody. So our challenge is how to make things like, and if it can include the picture, if somebody takes a picture of, say, a transformer fire, it'd be great to know where that fire is, and, or was that picture taken 6 years ago and somebody just downloaded it and moved it? And they just want to, have a, solve problems. They just want a utility truck to show up, say, throw rocks out. That's the kind of stuff we're interested in. How much of that is overlap with technology?
Well, this is just information, and where it's only as good as where you get the information from. I just heard a day or two ago that from a National Capital Area Emergency Operations Center that they tried to use Twitter data and it was no good at their level of resolution. 3% of Twitter data was geocoded, and it's usually geocoded to the town or the zip code, not really to the street.
Really, because the city of Toronto uses it, they actually catch trucks with it. It turns out if somebody knocks over a liquor store, they tweet all their friends about it. And as they're going back to their hideout, they're continually tweeting about how much money they had and stuff, and they follow them all the way back to their house and arrest them. And also,
and they're leaving the location reporting on.
Yeah.
That's a crook that deserves to be caught.
And during the Super Bowl, I've got a friend who has the Super Bowl, the municipality doing the Super Bowl used their system of tracking social media to look for potential threats.
There's a super stealthy Austin company called SnapTrends, which is one of the early leaders in real-time geospatial, not just that.
Yeah, a lot of that stuff depends on how trusting and savvy the public gets about whether they want to leave location on as they post to Facebook or tweet or Snapchat.
I'd like to.
I think I have one more slide I want to mention before you cut me off.
You already cut off. We've already gone to the questions.
We'll just go to GitHub, report issues on the POI format, and participate. That's open.
That's a great place to end.